Hello everyone. In this video we'll be looking at standard deviation as a measure of dispersion. So what do we mean by dispersion? Let's take a look at an example. Here we have a normal distribution curve centered on a mean, or average if you like, of 70. This could represent the frequency distribution of test scores, average annual income in a particular area, whatever. If we made a histogram based on collected data, and we had a lot of data collected, the frequency polygon might give you something looking like this. If we go with the test score example, in this situation the vast majority of students scored pretty well, bang on 70%. Some scored 70.1, 69.9, 70.2, 70.3, and so on. Scores further away from 70% are much less likely. This is a class of very consistent performers, maybe suspiciously consistent. The data is not very spread out. Now what if the scores were a little more spread out? We can see they're a little less consistent than they were before, but how do we communicate that more precisely? Well, that's exactly what the standard deviation is for. It gives you a precise description of how spread out a set of data is. So let's see how to calculate the standard deviation. In this question we have two groups of 5 students who received the following scores on a test. We have group A in front of us here, and there's a group B as well. We need to complete the tables for group A and B. So here's our calculator. And we can calculate the mean first. So we add up all the numbers, and then we divide by the number of numbers. There are 1, 2, 3, 4, 5 of them, and that's the mean, 78. For each of these numbers we're going to calculate the deviation. So whatever this number is, subtract the mean is the deviation. So for the first row, 94 minus 78. So the deviation of the first score is 16. The second is minus 22, 11, minus 11, and 6. Now for the square of the deviation, we just take each of these numbers and square them. So the square of 16 is 256. And then we squared negative 22, which is 484. The square of 11 is 121. Same for negative 11. And 6 squared is 36. Next we need to add up all the numbers in this column, which is 1018. And this sum of 1018 divided by n, which is the number of numbers. So we take this number, divide it by 5, we get 203.6. And then we square root this number, and that gives us the standard deviation, which is 14.27. And we can do the same for group B. The mean in this group is also 78. Next we'll calculate the deviation of these numbers. So 83 minus 78 gives 5. 76 minus 78 is negative 2. Same thing here. 81 minus 78 is 3. 74 minus 78 is negative 4. Next we're going to square these numbers. So the square of 5 is 25. Square of negative 2 is 4. Same thing here. Next we're going to add up all of these numbers in the column, giving us 58. Next we're going to divide that by 5. So 58 divided by 5 is 11.6. And if we square root this number, it gives us 3.4. So comparing these two groups, even though the mean for both of these classes is basically the same, results of the two groups are quite different. So the scores in group A are a little more spread out. And we can see that from the standard deviation of 14.27 compared to that of group B, which is 3.4. The scores in group B are closer together. If we consider a third group whose mean is also 78, we can see them represented here. How would the standard deviation in group C compare to the standard deviation of A and B? These scores look a little bit closer than A or B, so I would expect the standard deviation of group C to be smaller. Now that we know how to do that type of calculation on our own, let's see how it's done in our calculator. When we do the statistics, that's the number we're going to look for. We're going to use the statistical function on the calculator to determine the standard deviation of groups A, B, and C. So here's our calculator. We're going to edit the lists with the stat function. I'm going to put group A in L1, group B in L2, and group C in L3. So starting with group A, we have 94, 56, 89, 67, and 84. Now on to group B. And now for group C. Let's start with the one variable statistics for group A. Calculate one variable statistics, L1 is selected, and calculate. So the standard deviation is 14.3, which is consistent with our earlier result. And the statistics for group B, we're going to go stat, calc. This time we're going to select L2 because that's where I put group B. And the standard deviation is 3.4, which is also consistent with our earlier result. And now for group C, stat, calc. This time we're going to select L3, so we go second 3, calculate, and the standard deviation is 1.09. So we had 14.26 for A, 3.4 for B, and 1.1 for C. Was your prediction in the question correct? Yes. So now we're going to move on and do a few more examples with standard deviation. In question number 6, the field goal percent for 3 players for the last 10 games in which they played are shown in the table below. Calculator's ready. We enter the data. I've already done that for Anna, Patrice, and Morgan. So now we just calculate the statistics. So for Anna, we're going to select L1. The mean is 36.7. The standard deviation is 5.9. Now for Patrice, we go stat, calc, and we're going to select L2 this time. The mean for Patrice is 36.4, and the standard deviation is 1.5. And now for Morgan, we go stat, calc, make sure to select L3 this time. The mean for Morgan is 35.8, and the standard deviation is 9.0. So let's record that in the table. The mean for Anna was 36.7, the standard deviation was 5.9. For Patrice it was 36.4 and 1.5, and for Morgan 35.8 and 9.0. So which player has the most consistency? That would be Patrice, because the standard deviation is the lowest. And now moving on to question number 7. The bowling scores for John and Janine are shown in the table below. Determine the mean and standard deviation for the bowling scores for both John and Janine. So if we're going to enter this data into our calculator, it's going to be a little bit difficult to enter this into L1 because this gives a range of numbers. Our calculator won't accept this. So instead we're going to enter the middle number of each bin. So in the middle of this range is 103. In the middle of this bin is 108. The middle for this one is 113, and so on. So we could either do this the easy way or the hard way. If we do this the hard way, for John, we would enter 103 2 times, 108 5 times, 113 4 times. In total, we would have 72 numbers to enter, which would take a while. So rather than do that, we're going to enter the categories into L1, the frequencies for John into L2, and the frequencies for Janine into L3. So starting with the categories, we're going to go 103, 108, and so on. Now for the frequencies of John, 2, 5, 4, and so on. And the rows match up, which is great. And now for the frequency for Janine, 2, 2, 2, and so on. And the rows match up there as well, so that's great. Now let's calculate the statistics for John. So we're going to go calculate. L1 is our categories. Our frequency list is in L2. Calculate. So John's mean score is 129, and the standard deviation is 12.7. And now for Janine, we go stat, calc. L1 is the categories. This time we're going to select L3 because that's where the frequency stuff is for Janine. And the mean score of Janine is 133.5 with a standard deviation of 13.5. So we can record those results in the table. John had 129.1 average and a standard deviation of 12.67, and Janine had an average of 133.5 and a standard deviation of 13.54. So which person had the highest average score? That would be Janine with 133.5. Which person is most consistent? Whichever has the smaller standard deviation, which is John. And you can see the frequency distribution of John and Janine here. So John's scores are a little bit less spread out than Janine's, but Janine has the higher average. So now we're going to move on to question number 8. The following histogram displays the number of points a particular basketball player scored per game in the first 100 games of his career in the NBA. So he scored 6 points once, 7 points twice, 8 points once, and so on, just reading it off the vertical scale. So again, we can enter this data into our calculator the easy way or the hard way. If we do it the hard way, we would have to enter 6, 7, 7, 8, 9, 9, 9, 9, 10, 9 times, and so on. So that would be a lot of data entry. So rather than doing that, we will just enter the points per game in L1 and the frequency into L2. So we can enter the data into our calculator by going Stat, Edit. I've already put the points per game into L1 and the frequency associated with each into L2. It's important that the rows match up. So now we can calculate the statistics. We go Calc, making sure L1 is there and the associated frequency list is there, and Calculate. So the mean points scored per game is 12.56 and the standard deviation is 2.401. So we can record that on our paper. The mean points scored per game is 12.56 and the standard deviation is 2.40. I'm going to leave question 9 for you to do today. And we'll do question number 10 together. A mean of 10 scores is 12.5 and the standard deviation is 2.6. If 5.0 is added to each score, then the standard deviation will remain the same. So what happens basically is you have your cluster of data and it just shifts to the right. They are no more or less spread when they're all shifted to the right. So last, in general, a lower standard deviation indicates a greater consistency within the data. So that's it for me for today. You can also try these questions in the textbook, and I'll see you next time.